Hello, scholars, and welcome to Mr. Chambers Teaches HMH into Math for 5th grade. Today we are working on Module 2, Lesson 4. These are pages 47 through 50 in your Unit 1, Module 1 through 9 workbook. In this video, we will go through the Module 2, Lesson 4, spark your learning, build understanding, and step it out questions, and a few select questions from Check for Understanding and On Your Own. Feel free to skip around in the video to find help working on the particular problems you may need help on. Today in Lesson 4, we're going to be using partial quotients. I can use partial quotients to divide a multi-digit number by a two-digit divisor. In Spark Your Learning, Team Mudfooters is participating in an obstacle course marathon. For each obstacle the team completes, $99 is added to their prize bank. The team completes 12 obstacles. If each member takes home $66, how many members are on the team? So there's multiple steps to this problem. First of which, we need to figure out how much total money they have. We can find this by multiplying 99 times 12. Following what we learned earlier this year, we start with our ones. 2 times 9 is 18. Carry that over to our tens place. 2 times 9 is 18 plus 1 for 198. Now we move on to our tens place. We put a 0 as a placeholder and multiply 1 times 9 for 9. 1 times 9 for 9, and now we add this all up. 8 plus 0 is 8. 9 plus 9 is 18. 1 plus 1 is 2 plus 9 makes it 11. So we know that they have a total of 1,188 as their prize bank. Each member of the team walked away with $66, so we are going to be dividing 1,188 divided by 66. Now, before we got started, I went ahead and I wrote out all the multiples of 66 that I could come up with. I even went beyond the 10th multiple of 660 because I wanted to see if we could evenly divide 1188 divided by 66. It does look like we have a multiple down here that is divisible by 66, that is 1,188. If we count down our multiples, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, that this is our 18 multiple. And that would equal 1,188. Another way that we can think about this is 66 is divisible by 11. So is 11 and 88. If we divide 1188 divided by 11, 11 can go into 11 one time, minus 11. 11 cannot go into 8, so that's a 0. But it can go into 88 8 times. So we know that 66 or 6 now, because we divided by 11, into 108 will give us our answer. So 6 can go into 10 one time. 10 minus 6 is 4. Carry down our 8. 6 can go into 48 18 times. So by breaking up 66 into 6 times 11, we can find that our quotient is 18. So 18 members of the team completed 12 obstacles, and each took home $66. There are 18 members of our team. Throughout today's lesson, we are going to be doing partial quotients, looking at our divisor and thinking about how we can split it up into numbers that would be equal up to our total quotient. To help us build understanding, question number 1. Another team adds $594 to their prize bank. If each member takes home $54, how many members are on the team? Number 1, What equation can we write to model the number of team members that complete the obstacles? Well, we have 594 divided by 54. This will tell us how many members of their team complete it. We can start by estimating. And we have 54 and 594. Compatible numbers that we can use is we can make this 50 or 60, and our dividend we can either make 550 or 600. I like rounding up to 60 and 600 for about 10 team members. Because 60 is 1/10 of 600. All right, now we need to find the number of members that complete the obstacles by dividing using partial quotients. What number is the divisor and what number is the dividend? Our divisor is 54, and our dividend, or our total, is 594. Using our estimates, what multiple of the divisor can be subtracted from the dividend? And what is this multiple? Well, 54, I know that 54 times 10 would give me 540, and anytime we can use a 10 in math, that's pretty close to me, or pretty neat to use. So, what multiple of our divisor can be subtracted from the dividend? What is this multiple? 540, the 10th multiple. If I subtract 594 minus 540, that leaves me with a nice even 54. 54, which is the first multiple. If I subtract 54 minus 54, 0. There is no remainder, but I can add up that the 10th multiple and the first mean there are 11 members of the team. Okay, so we broke up our 594 into partial quotients. We could do the same thing using our area or array models that we used earlier in Module 2. All right, let's step it out. A county-wide field day registers 1,468 participants. Each participant will receive a ribbon. The ribbons are bundled in packages of 25. How many packages of ribbons are needed? We need to write a division equation to model the number of packages of ribbons that are needed and come up with a reasonable estimate. Well, if we have 1,468 and we're dividing this by 25, comparable numbers that we could use, or we could do 25 into 1,500. If we know that 25 can go into 100 4 times, 4 times 15 would give us 45 boxes as a reasonable estimate. Now, let's step this out, dividing using partial quotients. This requires having our multiples of 25, which we know are 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, 275, 300, and it could keep going on. I like 250. It's a multiple of 10. How many times can 250 go into 1,468? Well, at least 250, 500, 750, 1,000, 1,250. Okay, so 1,250. So that was 1, 2, the 10th multiple times 5. Okay, so that's the 50th multiple of 25. Nope, that seems wrong. My apologies. 10 times 2 times 3 times 4 times 5. So 50th multiple. Maybe my estimate might be wrong here if I'm already at 50, but we'll see. Okay, so now we can subtract 1468 minus 1250. This will give us 8, 1, 2, 218. The closest I could get to this is 1, 2, 3, 4, 5, 6, 7, 8 multiples of 25. With a remainder of 18. Okay, so we're piecing this together. And now I'm at 58 packages with a remainder of 18. So my whole number quotient is 58 with a remainder of 18. Well, you can't give away, or you can't just buy 18 ribbons, so we round this up to 59 packages. Somewhere in my estimate, I was a little low, only estimating 45. But sometimes we make mistakes, and sometimes we can come back here and we can re-examine our estimate. 25 into 1,500. 25 could go into 150, 1, 2, 3, 4, 5, 6 times. That's better. Minus 150. Carry down our 0. We estimate approximately 60. So sometimes we make errors, and that's okay. All right. We are going to be doing Check for Understandings, questions 1 and 3. Question 1. There are 439 flower seeds in a packet. A gardener fills 36 seeds into each starter tray. How many trays can the gardener fully fill with one packet of seeds? So our total number is 439. We're dividing it into 36 spots for this. To help us out, we're going to do some multiples of 36. We have 36 plus 36. 6 plus 6 gives me 12. There. 72. Plus 36. Add this up. 8. 108. Plus 36. So this is our first multiple, second, third. Every time, if I just need to add up or skip count, I can. It's better to take the time early on to find our partial products. 108 plus 36. 4, 10. 144 plus 36. 10. 8. 180 plus 36. 9. 11. 219 plus 36. Add this all up. Got 5. 255 plus 36. 6 plus 5. 11. 9. 2 plus 36. 7. 27. Did I get a 7 there? That's 11. Yep. Okay. Plus 36. So that's 2. 1. I must have made an error somewhere because 36 times 10 should be 360. So I'm piecing out all my possible multiples. And this is taking me a while. So maybe I might want to consider 36 as a factor of 9 and 4. 9 looks like it could go into 439. So let's test out if we could break up 439 divided by 9. 9 goes into 43. That looks like it could go in 4 times. Minus 36. 13 minus 6 is 7. Carry down my 9. 9 can go into 79. Approximately 8 times. 72. This gives me a remainder. Not sure if that's the best factor to go about. And as you can see, it takes a little bit of time, a little bit of practice. Try to figure out the best way to split up 439 by 36. Well, if I go back to my multiples here, 439. Down here, I have 219 as a possible one. If I do... I don't think that path was leading me in the right direction. So if I go to here and I subtract 219 from here, that leaves me with 0 to 20. And I got 219 as my 6th multiple. So 36 times 6 gives me 219. I can get there again, another 6 for 219. Leaves me with a remainder of 1. So I have 12 trays. Okay. So 12 trays gets me here. Alright. I'm sorry for the confusion, but sometimes we just need to work it out to piece it together. Another easier way that I just realized I could have done is 439 minus 360. Anytime I could have 10, that makes life nice and beautiful for me. So that's times 10. If I subtract this out, 9 minus 0 is 9. Borrow and regroup, 13 minus 6 gives me 7. 36 times 2 gets me to 72. And if I do this, it's a remainder of 7. So 10 plus 2 equals 12. We can fill 12 trays completely. Yes, we have that remainder. But sometimes I just want to break it down into my partial quotients. And anytime I can use a 10, life is good. I apologize for the confusion, but we do just need to try it out sometimes. All right. Problem number 3, figuring out how many times 39 can go into 5836. Well, if I times by 1,000, or if I know that this is 13 times 3, maybe I can break up 5,836 by 3. 3 can go into 5 one time, minus 3. 3 can go into 28. That looks like that's going to be 9 times, minus 27. It's 1, carry down by 3. 3 can go into 13 4 times, minus 12. 1, carry down by 6. 3 can go into 16 5 times. Okay. All right. So now I can figure out how many times can 13 go into 1,945. To do this, 13 can go into 19 one time, minus 13. That gives me a 3. 40, 34. 13 can go into 34 twice. That's minus 26. 34 minus 26 is 8. Carry down the 5. And figure out how many times can 13 go into 85. Quickly write out my multiples here. 52, 65, 78. 78 is my closest multiple. 1, 2, 3, 4, 5, 6. 78. All right, 85 minus 78. 2 minus 8, 7. All right. So if I add up my two partial quotients, 1,945 plus 126. 5 plus 6 is 11. 4 plus 2 is 6 plus 1, 7. 9 plus 1 is 10. 2,071 times. Okay. So this seems a little messy. We tried breaking it down into partial equations. We find that 2071 is our answer. But if I double check my math, I notice that 2071 times 39 is going to give me a product a lot bigger than 5,836. All right, trial and error. We figure this out. So one step at a time. It's okay to make mistakes. Yes, I know I seem to be making quite a few of them, but I just want to make sure that as I'm explaining this, you see the mistakes I'm doing, see my thought process. And we're divided by 39. All right. Let's make an estimate. Before we get too crazy, what if I make this 40 and I say that that's 6,000? As an estimate, about 40 can go into 60,000 times. Take off my placeholder zeros. What's 1/4 of 600? Can go into ones. Carry down the 2. That's a 5. 150. Okay. So my answer was a little off. A place value ahead. Going back and estimating, I now realize that I'm looking for an answer that's approximately 150. So where did I go wrong? What can I do differently now that I've done this? Well, start off, let's write out some multiples of 39. I have 39 times 1 is 39. 39 times 2 is 78. Plus another 39, 117. Plus another 39, 156. Gonna keep doing this, dividing by different multiples. 195 plus 39, 234 plus 39, 273 plus 39, 312 plus 39, 351 plus 39, 390 plus 39, 429 plus 39, 468 plus 39, 507 plus 39, 546 plus 39, 585. All right, so writing out my multiples of 39, coming back and try this problem again. Remember, we estimate about 150. So let's see what we got. Coming down this list, going down to 583, my closest multiple without going over is 546. To get there, I multiply by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 14 times 39 gives me 546. Subtract this out. That turns to a 7 because I need to regroup. 13 minus 6 is 7. 7 minus 4 is 3. All right, now I can carry down my 6, and I'm looking to see what multiple of 39 is close to 376. 390 is close, but it goes over, so I go to 351. Be subtracting 351, which is our first, second, third, fourth, fifth, sixth, seventh, eighth, ninth multiple. So I'm multiplying times a 9. 6 minus 1 is 5. 7 minus 5 is 2. All right, this seems much better, much more reasonable than going through the last time I did it. Our answer is 149 with a remainder of 25. Yes, it took us a while. Yes, we made mistakes, but we can check our work and work backwards through it. We have 3 more problems that we're going to be doing together on page 50, page 5, or question 5, 7, and 9. Question number 5. A third team earned $891 in their prize bank. Each team member received $81. How many members are on this team running? So our dividend will be 891 divided by 81. Before we get started, let's make an estimate. I see that I have 80 and I have 891, which I'm going to use comparable numbers of 80 and 800. Reasonably speaking, my answer should be about 10. It's not going to be perfect, but let's keep that in mind. Knowing that it's about 10, if I multiply 81 times 10, and I can subtract 810. If I subtract 891 minus 810, that leaves me with 81, which 81 can go into 81, or 1 time. And so our quotient is 11. This one's a little easier. This one's just breaking down. Hey, what's my closest multiple to this number? And anytime we can use a base 10, it's going to make life so much easier here in math. I'm sure if I go back to our last problem and I remembered my multiples of 10, we could have gotten to our answer a lot quicker. All right, on to number 7. Let's start by estimating. I have 31 and 682. 31 can be comparable to 30, and 682, I think we can round to 690. Take off that 0, 3 can go into 69, 13 times. So I estimate that our answer should be approximately 13. Now that we have that, let's check this together. Well, let's start by minus 310. That's a multiple of 10. We can use that. Oh, I'm sorry, that's 23 is my estimate, because 3 can go into 6 2 times. Got a little carried away with this, but 2 minus 0 is 2. 8 minus 1 is 7. 6 minus 3 is 3. I could do another multiple of 10 to subtract 310. This gives me 62, and 62 would be 2 times 31. So our total answer is 22. By using our partial quotients, or our multiples of 10, we subtract out this, and what we're left with, 62, it can evenly be divided by 31. So we estimated 23, we got an actual answer of 22. So this will work. All right. Last problem of this lesson. We need to find out 62 and how many times it could go into 7,588. Let's think about our estimate. Round this to 60. And if I think about my multiples of 6, I could know that it could go into 72 or 78. Let's try 7,800. Could go in. 6 could go into 78 one time. 6. Down 8, 3. 130 is my estimate. Okay? So, think about our multiples of 10. I could do times 10 and subtract out 620. 758 minus 620. Carry down 8 minus 0 is 8. 5 minus 2 is 3. 7 minus 6 is 1. Okay. I think I could get in a little bit closer. Carry down my 8 here. All right. Let's do another multiple of 10. And subtract out 620. 8 minus 0 is 8. 8 minus 2 is 6. 13 minus 6 is 7. Okay. I could do one more multiple of 10. Minus 620. I'm sorry for the pause here. I'm just realizing my estimate seems a little bit off. About 3 groups of 10 here. This is a group of 10, as I should say, because it's a group of 100 minus 6,200. There's where we got off track. So this top one is where I made my mistake. I should have multiplied by 100 because I was subtracting 6,200. Then minus 10 for another 620, minus 10 for another 620, and I'm at 148. Multiples of 62, I have 124 and 186. All right, so I can divide by 2 minus 124. This gives me a remainder of 24. If I add this up, I have 100 plus 10 plus 10, 120 plus 2, 122 with a remainder of 24. Okay. Now this is our last problem, and I know I had a few hiccups trying to figure out how I could get to my estimate of 130. Now that we know that our answer is 122 with a remainder of 24, let's think about other ways in which we could go about doing this. What about my multiples? Multiples of 62. 62 times 1 is 62. 62 times 2 is 124 times 2. I'm sorry. 124 plus 62, 186. Plus 62, 248. Let's think about our multiples here. 372, 62, 434, plus 62, 496, plus 62 is 558, plus 62 is 620. Okay. Maybe I need a few more because I want to get as close to 758 as I can. Let's try to piece this all out. This is just kind of showing you what we're getting into in Module 3 with some long division. Okay, 682 plus another 62, 744. Plus 62, 806. Okay, I've got over 744. All right. So 62 can go into 75 one time. Minus 62. This becomes, carry that down, 138. I can get there close by doing a 2. Minus 124. 138 minus 24 leaves me with 14. Carry down my 8, and 148 I can't get to, but I can by 2. 1 minus 124 leaves me with a remainder of 24. So no matter how we do it, yes, it takes us a few trials, a few errors, but we can find that the quotient is 122 with a remainder of 24. Sometimes I just like to double check my work and make sure that I've got the right answer. So, this will now conclude our video on HMH into Math for 5th grade. I'm Mr. Chambers, and I thank you for taking your time to watch this video to improve your math skills, and I look forward to speaking to you again in our next lesson, our Module 2 review.